Hi, welcome back to the old shop. Want to thank you all for tuning in, and especially thank those that have subscribed to this channel. It's up to about 2,600 subscribers now, and that's really contributed to putting this channel on the map for folks who'd like to see what vintage machine shop, old school machine shop work is like. You know, old school machine shop, that's machine work before digital readouts, some people think, but it's really older than that. This is geared to, say, 1920s, and this was during the second part of the Industrial Revolution that really put this country on the map, and this is how it was done. I got a few donations that showed up for the shop. I'll show you in a minute. And haven't had anything really interesting come in to do, making bronze bushings and drilling a hole in this and cutting this down a little bit. So for the machine work part of this, I'm going to continue on to some projects that I've been working on here. You've seen them before in the other videos. One thing I wanted to do was make a new split bushing for my boring tool. I made this a long time ago for the American lathe because it had no tooling on it when I got it at all. And this is just a block that holds an 1.25 inch boring bar. And I wanted to adapt it to a 1-inch bar, so I made a split bushing that would clamp down on it. And when I made it, I screwed up and I cut the inside diameter about 10 thousandths oversized, so it never really clamped down on there good. So one day I got really hacked off at it and I decided to make another one. So that's in the lathe now, and it basically is just a simple bushing, 1.25 inch OD, 1 inch inside diameter split. So we'll be working on that. I'm going to convert the Brown & Sharpe milling machine to the line shaft. I never got around to doing it, but the spacer block for the dividing head, which I was working on in the last video, is going to be the last job that milling machine will ever do under electric power in this shop. I have to cut a groove on the top and the bottom for the keys that engage into the table and up into the dividing head, and well, we're going to do that. And this is the pulley for the Brown & Sharpe, and I'll show you what my plan is there. We'll move over there to that. Well, the original thought, of course, is to put another jack shaft in over here with a tight and loose pulley for a clutch, and then belt straight down to the machine with a stepped pulley. I have to move the milling machine over here underneath that. But I think for the time being, what I'm going to do is I'm going to take the motor off it, but I'm going to leave the gearbox, and I'm just going to belt straight down from this pulley to here. This needs to run 700 RPM, and with an 8-inch pulley on this, that's just about what I got. So I need to make a bushing to bush that pulley to match this shaft, and while I'm doing it, I'm going to make the bushing offset so the pulley will be out a couple of inches, so I won't have to move the milling machine out because I don't want to lose any more of my walkway area here. So that's the plan. Of course, the machine has to be leveled up so the belt will run straight and all that kind of stuff, but that's what we'll be doing. Also, later on, I had something in the shop that I thought would be interesting. It's not really related to the steam part of the shop, it's in the engine part, but it's a big shaper that I have, and I had a tractor head. It was off a John Deere Model R. It's a 2-cylinder head, and it's about maybe 18 inches by 24 inches, and I didn't have any machine in the engine shop that could resurface that head. So I set it up on the shaper, and I'm just going to show you how that job went. Also, at the end of this video, I've got some clips from a trip that my wife Debbie and I took out to Ohio to visit a friend of mine who was also was a volunteer on the East Broad Top Railroad restoration, and he has built a complete small gauge steam powered railroad on his property. Hand built the locomotive, all the rolling stock, everything, and I brought back some clips from that, and I thought you might be interested in seeing that. So that's where we are for today, and we'll get right going.
This is probably one of the few shapers that's actually making a living today. Cutting this John Deere diesel head. Head's about 16 inches across, 24 inches wide. Bore on this engine is about 6 1/4, and this is a 32-inch stroke shaper, and it's the only machine I've got that's big enough to do this job. It's about a 10 thousandths cut at a 30 thousandths feed. It's doing a pretty good job at 32 thousandths. You sort of have to make a balance between find enough feed to give you a good surface finish and having a coarse enough feed so that you can get the job done sometime this week. It takes a long time to get across there. I've got the John Deere head set up to resurface the manifold side. Got the indicator on there, and I've been tapping it a little one side or the other, and I got it so she sits about still. This is the finished cut. It's 5 thousandths cut, 10 thousandths feed, 34 strokes per minute. And that'll give it a really nice finish for a gasket. there it is. I'm going to split it before I cut it loose. It's going to be easier that way. Decided to bore this sleeve, drill it 15/16, needs to go to 1 inch. I'm going to drill it 15/16 and then bore it after I have it pressed in the pulley. And I want to line up the goji of the pulley because those cast iron pulleys a lot of times don't run very straight. So this is going to be the final cut, and then I'm going to press it. It's the last pass of the last side on the aluminum block. Okay, we're going to lay this out. I'm going to put a key on each end of this in a keyway, and I got to cut this down to 6/12 because this is what the groove, what the T-slot width is in the milling machine. So first I'm just going to put a center line down through here, and this is 7 3/4. So half of that would be 3 7/8. So I'll put this side of the scale right here is an 1/8. So we'll put this right in the mark. Okay. And that'll be the reference that we'll work off of on the milling machine. Do the other side too. Quick little job for the shaver. I've got to take that key down to 6/12. And then flip it 90 degrees. Take it down to 6/12 the other way. $6.23. 11 to go. 5, 10, 11. Okay, there it is. The key made out of a piece of junk stock. I got 6/12. Just a couple tenths under 6/12. And this way we got we got 611.5 on that end, and 605 on this end. I think I know what happened. When I set up the second side, I had the vise too tight when I knocked it down against the parallels, and I don't think in the back it went all the way quite down against the parallel, but it won't matter because all it's going to do, one side is just going to hang down into the table T-slot anyway, so we'll use the good side dimension to go in the slot. Okay, so the block's mounted in the Brown & Sharpe milling machine. can see how these offset clamps are pretty handy for mounting stuff like this, because they give you clearance under here if you're mounting something flat. So that works pretty good. I don't know if you can see it. We've got the pointer right over the line that we scribed, and if I run it from one end to another, it's right on top of the line. So that should be lined up close enough for what we're doing here. The way they would have done it in the old days without dial indicators. And the plan is when we get the this side done, we'll put the keys in it, flip it over on the table, and actually put the keys right down into the T-slot, so that when we cut the slot on the other side, the two keyways will be lined up with each other. That's the most important part. Whether this is lined up this way is not a critical dimension on this project. The most important thing is to have the two keyways lined up with each other on each side. I have to reverse the feed direction and speed it up a little bit for this job, and the way you do it on this old milling machine is you cross the belt to run it backwards, and we're going to speed it up to about here. See, now we're cutting aluminum, and run a little higher feed rate. I actually went ahead and laid out two lines, one each side of the center line. That's right where the slot's going to be 6/12 apart, and I've got the cutter lined up by eye right on this first outside line. We got to go about 300 thousandths deep. And I'm going to try to do that in 3 passes with this little cutter. I don't have a 1/2 inch cutter. This is 3/8 cutter, but it'll work. I'll just set it over. We'll make a little trial cut, actually measure the width, and then make adjustments from there. Our Y-axis feed here is 100 thousandths per turn. It's got a crude little mic head on it. Go by that. I'll just bring it up, touch it. The arbor is also sprung. So it's going to be cutting on just a few teeth. Okay, there's 50. There's 100. Gauge the feed. Away we go. Well, there's the finished slot. It's pretty good. Fairly accurate work for a 130-year-old milling machine. Now we'll cut the slot on the other side. I think we'll wait till next time to do that. Well, thanks a lot for watching. We're gonna end up this video with some clips from my friend Jim Bacon's backyard railroad. Just keep in mind when you're watching it that everything you're looking at was totally scratch built, except for the rails and some of the accessories on the boiler. In fact, the boiler was replaced this winter. Jim welded up a whole new boiler for it. It's pretty amazing stuff. We had a good time. Thanks again. Catch you next time.